Okay, so now we're looking at the another circle theorem proof, again using GeoGebra, which I think is just an amazing resource for teaching maths, and I'll be using it more and more. Yeah, I won't go on about GeoGebra, but it's very, very good. Basically, what this rule is saying is that if I were to draw a line, if I were to draw a line from the edge to the center and to the edge, and then from there to the other edge and back to the beginning again, then this angle here will always be double this angle here. Now, experimentally, we can play around with this and we can see is that always the case. So let's just try to find a nice sort of whole number. 140 roughly, 170 roughly. I'm sure if you get a calculator, there's going to be a bit of a rounding error here. If some of you are pretty good at mental arithmetic, will see that 70.2 is times 2 is not actually equal to 140.3, but that'll probably be because that's actually 70.15 maybe, and this might not be anyway 140.3. But the point is, if you get a calculator out, you'll see it's roughly equal to it. I'm not sure if you're able to edit that angle, redefine. Oh, okay, never mind. So yeah, basically we're going to try to prove that that's the case. So I'm going to just give myself a bit more space here. I'm going to just delete the angles for now, or hide them. And I'm going to use the pen tool around here, which I've just discovered, so I'm very, very pleased about. I haven't used it yet, so I don't want to get too excited, but let's see. Well, I think actually what we're going to do first is, I just realized another more important thing would be to get a segment and go from here to here. So I'm not changing anything about this shape apart from I've just connected 2 points, and in doing so I've actually identified 2 isosceles triangles. Notice that F to H is the radius, F to J is the radius as well, and they've also got this triangle FIJ, which is F to J is the radius, as I said, and F to I is the radius. So I would predict that FHJ is one angle, is whatever FHJ is going to be the same as FJH. So this angle here is going to be the same as this angle here. You can experiment with this yourself by there's a link in my database to this thing here to this simulation I'm playing around with right now. I've made a link to it. In fact, if you zoom out, there's another one over there, and as I make these videos, there'll be all of the circle theorems which you can play around with. So let's get my pen then. Let's see how well this pen works. So if I identified these isosceles triangles, we can say that angle there is x. It's a little bit thick. I wonder if I zoom in, would it make it a bit thinner? Let's see. Okay, what would happen now if I drew on my... Let's get a pen tool again, and... Okay, same thickness, never mind. We can do with it. So that's X. I'm going to call this one W. I'm going to call this one Y. And over here, we're going to call this one Y as well, because that's also an isosceles triangle. I'm going to call this one X, Y. Let's call this one Z. And we've got the remaining angle here. Well, we're going to come back to that angle in a moment. So angle X, these 2 angles are the same, and we know that all angles in a triangle add up to 180. So that must mean that 2x plus w equals 180 degrees. And for the same reason, 2y plus z is also equal to 180. So that should be useful, shouldn't it? And around here, the points around the center here, Well, these all add up to 360, don't they? So that means that this angle here is actually going to be 360. Let's try that again. Is it going to let me erase that? Okay. Not sure how to erase things yet, but I'm sure there is a way. They want to put a pen, but not an eraser. 360 minus W minus Z. And what we want to try to do, I guess, is say that this angle is the same as this angle. This angle up here is x plus y, basically, isn't it? And so we're going to say this is hopefully equal to x plus y. So, okay, so how are we going to go about doing this? Well, we could say that, let's rearrange, let's identify some of these equations. So this is equation 1, and this is equation 2. And we'll say that we're going to rearrange to say that we're going to rearrange equation 1. We'll say 2x is equal to 180 minus w. I'm going to rearrange equation 2 to say that 2y is equal to 180 minus z. Okay. Right. Now, what's next? Well, we want to say we're trying to work out what is x plus y. Well, okay. So what is x plus y in terms of w and z is essentially what we're trying to do, aren't we? So we've got, let's say we. Okay, I'm going to just pause this for a moment to have a little bit of a think. Okay, I think what I'm going to do actually is I'm going to rearrange this to be. So we're going to say rearrange for w. So we're going to say that w is equal to 180 minus 2x, and z is equal to 180 minus 2y. And then we're going to say that 360. This angle is equal to 360 minus w minus z. So 360 minus 180 minus 2x. That's supposed to be a bracket. Minus 180 minus 2y. Okay. And what we should find is it's going to be equal to 2 lots of that. So it's looking pretty good actually, because we want it to eventually equal to 2x plus 2y. And I think if you, some of you might be able to do this in your head, and you'll be able to see that that is going to be what it's going to be equal to. So let's just do the rest of the stages there. If I can find the pen, there it is. So expand out the brackets. We've got 360 minus 180 minus 180, and this is going to be plus because we've got the two minuses cancel out, so plus 2x. Again, these two minuses turn into a plus 2y, and you can see that 360 minus 180 minus 180, we end up with 2x plus 2y. So this angle is therefore equal to 2x plus 2y. This angle is equal to x plus y. So therefore the two angles added together. So this angle is equal to double of this angle. So yeah, I hope that made sense, and feel free to play around with this yourself on the simulation.